Hi everyone, and welcome to Chapter 7. We're going to learn a whole lot about trigonometry. We're going to learn about something called the unit circle this chapter, sine function, the cosine function, the tangent function. So today we're going to mainly focus on different trigonometric functions, what they are, and their definitions. So let's begin. We'll begin day 1. We always begin with a warm-up, so let's try it out. Okay, we're going to solve for x. Now think about what you remember about right triangles, pause the video, see how well you can do solving for x in this problem. Okay, so hopefully you saw a right triangle and sides and you remember Pythagorean theorem, where a squared plus b squared or x squared plus x squared equals 12 squared. We can combine like terms and we can simplify by using the division property, and then we can take the square root and we can simplify the square root. Now, if you had the square root of 72, that's great. I'm going to simplify my radicals, and we're going to see why momentarily. This is going to be a special right triangle. We're going to learn what the angles are, but if I know this type of triangle has congruent legs, then I can find the hypotenuse without using Pythagorean theorem. And that's due to trigonometry. So we're going to start with what is a trigonometric ratio. So hopefully you've seen sine and cosine and tangent in the past. Whenever we're given a triangle with an angle, okay, we like to label the angle. A lot of times we use theta. We can use x or y, whatever variable we want. Now the long side, the side opposite the right angle, is always the hypotenuse. And then based on where your starting angle is, the angle across from it is the opposite side, and the angle next to it is the adjacent side. Whenever I'm doing trigonometry, I always recommend when I have draw a picture and label the opposite, the adjacent, the hypotenuse. And that is the Greek letter theta, kind of like looks like a 0 with a horizontal line in it. Now, according to this diagram, there's different ratios. So the 6 basic trigonometric ratios of the functions, the sine of an angle is equivalent to the opposite over the hypotenuse ratio. The cosine is equivalent to the adjacent over the hypotenuse. And the tangent is equivalent to the opposite over the adjacent. And you may have seen this word before. You may have seen SOHCAHTOA, which is very useful in remembering what these 3 ratios are. Sine equals the opposite over the hypotenuse. The cosine of the angle equals the adjacent over the hypotenuse. The tangent of the angle equals the opposite over the adjacent. Now, that's going to be extremely helpful when we set up equations, when we solve equations, or when we're just looking for ratios. Now, 3 ratios that you haven't seen probably are called the reciprocal trig ratios, are cosecant, secant, and cotangent. Now, cosecant is hypotenuse over opposite, and secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. But I don't remember them that way. I remember them as the cosecant is the reciprocal of sine. So if I know the sine ratio, I know whatever fraction that sine is equivalent to, I flip the fraction. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Now, something to be careful about. Cosecant goes with sine. A lot of students tend to mess up and they say, oh, cosecant, cosine both start with C, but cosecant is the reciprocal of sine. So if we can get these 6 ratios down, we can do a whole lot with solving trigonometric functions. Or the problem may just ask you to write some ratios. And that's what we're going to start with. So problem may just ask, if this is theta, if this angle up in the top left of the triangle is theta, what are the different ratios? They may ask you for one of them, or in this case, they're going to ask you for all of them. So the first ratio I'll start with is sine. So sine is the opposite over the hypotenuse. So sine of theta equals 21 over 29. Now you don't have to write opposite over hypotenuse every time. Once you start practicing it, you'll remember what the ratio is, and you can just write the fraction. If it helps you to write the intermediate step, great. So we have sine as the opposite over hypotenuse, and cosine and tangent. And the order of these numbers matters. Do not write 29 over 21. Don't do hypotenuse over the opposite. That's a different ratio. Okay, now we need the reciprocal trig ratios. And as we were talking about before, the sine, if I take the reciprocal of that, I get the cosecant. So I don't have to remember cosecant as hypotenuse over opposite. I can remember it's the reciprocal of sine. So if I find sine, I can find the cosecant. Same thing with cosine and secant. Same thing with tangent and cotangent. And this really is helpful if I label my sides, opposite, adjacent, hypotenuse. Those details are crucial. So now you try it. Here's a triangle. I want from this angle theta, you tell me the 6 trigonometric ratios. Pause the video. When you're ready, we can go over some of the answers. Okay, let's take a look how you did. So there are the 3 trig ratios. We'll get to the reciprocals in a second. But I always like to make sure I label the hypotenuse, the opposite, and the adjacent. And since I'm a little bit lazy, I like to just use H, O, and A. So if I was looking for tangent, I have the opposite over the adjacent, I have 5 over 12. Same thing with sine and cosine, I figure out what the ratio is, and then I write the correct fraction. Now cosecant, secant, and cotangent, take the reciprocal. So I know sine already, so I now know cosecant. Same thing with secant and cotangent. Okay. SOHCAHTOA and remembering the reciprocal ratios is going to help me a ton. Now this is a very important concept, so let's try another one. Okay, the triangle looks a little different this time. Pause the video, take a shot at it. Let's see if we get it right. Okay, let's see how we did. Okay, there's all 6 this time. Hypotenuse across from the right angle, opposite, adjacent. And eventually you'll get to the point where you might not need to label the sides, but it doesn't hurt. All those little details give us hints and clues to make sure we are correct. And then once again, cosecant, secant, and cotangent are just the reciprocals of the first 3. So we'll get really good at the first 3, and then the second 3 are really advanced concepts. Now, a problem could give you this. Could say the tangent is 15 over 8. The tangent of the angle is 15 over 8. And what are the other trig ratios? So this is kind of like a puzzle where we need to draw a picture and label. So that's what we're going to do. Okay, I'm going to pick the angle up here. We could have also drawn the picture so we have the angle here, and we could have 15 over 8. Both pictures are the same. Okay, I don't know the hypotenuse. Okay, and that's what I'm going to need for all the ratios. So draw the picture. Okay, if you don't draw the picture, I don't know what you're going to do. Step 2, use Pythagorean theorem. Okay, find the hypotenuse is 17. If I need all the ratios, that means I need all the sides. If I see right triangles and I have two sides, I can always find the third one using Pythagorean theorem. So I have an 8, 15, 17 triangle. I would write that on my picture. Anytime I get information, I add it to my diagram. Then I find all the ratios. Okay, then it goes back to the problem before where we just look at the triangle, we start at the angle, and we find the ratios. So tangent was opposite over adjacent, sine was opposite over hypotenuse, so sine is 15 over 7. Okay, cosecant is the reciprocal of sine. Okay, so this should be 17. There's a missing one there. Okay, reciprocals, find the ratios, and you got it. Keep practicing it. Now you get to try. Okay, I'm telling you the sine of an angle is 24 over 25. Pause the video, draw the picture, get all the ratios, and let's see how we did. Okay, we're ready to go. I'll draw the picture that I had. I, for some reason, always like putting my angle in the bottom right corner. I always like drawing this exact right triangle. I have no idea why. Probably because how I learned it. So 24 over 25. And if you learn some Pythagorean triples, which are three numbers that always make a right triangle, okay, you wouldn't have to use Pythagorean theorem, but if you did, you'd still find that this length is 7. So sine, cosine, tangent, all the ratios, take the reciprocals, and continue to draw the picture and take your time. Now, one of the very important reasons why we use trig is to find missing sides and angles. So we have a situation where a fire truck has an 84-foot ladder, okay, forming a 55-degree angle with the building or with the top of the truck, and we want to figure out if the ladder is tall enough to reach the window. Okay, we don't want to do trial and error. We want to use angles and triangles to figure out before we have to arrive at the scene. So the height of the window is 75 feet off the ground. It says the truck is 8 feet, or the top of the truck is 8 feet. So I'm going to label this as 8. And then we're going to solve. So will they be able to get the ladder up the whole 75 feet? We're going to see. So when we get a situation problem, we draw the diagram. Okay, we know we're starting 8 feet above the ground. The ladder is 84 feet, 55-degree angle. We need to find, okay, the height of this side, the wall side. And then we can figure out whether we have enough ladder. So step 1, always draw the picture. Label everything, okay, with all the known information, even if we're not going to use it. Then decide which function to use. So we know the hypotenuse. We're looking for opposite. I don't really care about the adjacent, but I'm going to label it anyway. So opposite and hypotenuse is sine. So we're trying to find x here. We're trying to find the height that the ladder touches up on the wall. So we have sine of 55, sine of the angle. Now we have an angle number equals the opposite over the hypotenuse. Now we're going to use the calculator. Sine of 55 is a number. It's going to be a number between 0 and 1. And we're going to solve for x. So we're going to multiply both sides by 84. We know how to isolate the variable. And we're going to type 84 times sine of 55 in our calculator and get about 68.8 feet. So the height from the top of the truck, the wall is 68.8 feet with the straight decimal. Okay. Now I've solved for the missing side, I got to answer the question. So how I do that is I figure out that from the ground up to the top of the truck is 8 feet, plus an extra 68.8 feet up in the air, which is 76.8 feet. The question asks, can I get to a window that's 75 feet tall? So the ladder is going to go up to 76.8, which is above the window, so I'm good. Okay, I can always lower it to get to 75 feet because I have enough room. Okay, so that's how you answer a trig problem. Draw the picture, label the sides, set up the equation, solve for x. Whenever I say we're solving an equation, we know how to solve for x. It's really crucial that we set up the correct equation. We're going to end with you trying one today. Okay, sun shines at an angle of 60 degrees to the ground. How long is the shadow cast by the 20-foot tall flagpole? Draw the picture, set up the equation, use the correct ratio. Go for it. Show yourself that you can get it right. And when you're ready, unpause the video and we'll take a look. Okay, so here is the information. Okay, I had 60-degree angle with the ground. I knew the flagpole is 20 feet high. I want to know the shadow, which is along the ground. I don't really care about the hypotenuse. I care about the opposite and the adjacent. So that's why I use the tangent ratio. Now, x is in my denominator. I'm still always multiplying both sides by my denominator. So I multiply both sides by x. I divide by the tangent of 60. And I do that on my calculator. 20 divided by the tangent of 60 is 11.54 feet, which is how long the shadow is. So today we learned about trigonometric ratios, the 6 of them: sine, cosine, tangent, cosecant, secant, and cotangent. We learned how to write the ratios, and then we learned how to find a missing side. And in the next lesson, we're going to explore more information about these trigonometric ratios.